So what's going to have gone wrong here is my clever code is going to be wrong because it's clever. And it shouldn't be clever, it should be stupid. So we should make it a lot dumber. We should make it idiotic, stupid. Alright, so what we're going to do is we're going to get our angle from our integer. No, we're not going to do anything with these frickin' angles. What we're going to do is something even dumber. We're going to make an f vector 2d vec, which is going to be wx, wy. I don't even know what the hell w stands for. And what we're going to do is, this is going to be the direction that we're going to be at, that we're going to want to go. And I guess we can rotate this vector, so let's do just vec.normalize. Yeah, let's just do if wx equals 0 and wy equals 0, then we're just going to return false. And at the end of this, we'll return true. So we'll kill our particle. So we'll set this to a bool for a tick. Alright, so move particles and spawn particles. Alright, so we're going to want to use this doubly linked list. Alright, so it's going to be like it's going to be doubly linked list node pointer cur equals m particles dot get head, and while cur does not equal null pointer, cur equals cur next node. So we're gonna get cur get value dot tick. So we're gonna if not, so if the update says we should remove this, then we're gonna want to remove this node. Is there a remove node? Delete node. So we'll just do m particles dot remove node cur. And does remove node return anything? It does not. So we're gonna have t double linked list node star flow path particle. equals what? Cur. I guess get next node or get prev node. Yeah. So the previous node will be get next node. So that's what we'll always do, and we'll remove the current one, and it'll be just call it next, and we'll just say cur equals next. Continue. So why is this giving me trouble here? We should be able to call getHead, which should give us the t-double-linked list node pointer. Let's see if anybody in the entire code base uses this. Ah, somebody does. Well, let's just see what this compile error is pissed about. I don't think it's really going to be mad about anything. What, TW-link list node is not identified? Oh, come on. It's inside of this thing. Do we have to actually include list.h or something like that? I mean, we might actually have to include containers / list.h. Let's see if we do. TW-linked list node is not identified. I don't understand how it's not identified. So we go to list.h. It's inside of TW-link list. Okay, that's probably what is going on here, is we need to Alright, the list node is not templated, this other thing's templated, so we need this to be in here like that. Templates are kind of odd for how they need to be declared, so, you know. Alright, so that'll get them there. Okay, so spawn particle is going to be fine. This tick, we're going to need to do something about this. Alright, so we're going to return false if this particle is on the place. We're going to try to move towards the particle Alright, so it's going to be like for, int I equals 0, I is less than 100. Well, it's not 270. What is? I guess it's 225. So what we're gonna do is we're just gonna call like, is there like rotate vector? Just like a simple rotate. Yeah, get rotated angle degrees, and we're just gonna pass in the degrees. How come it said that there was a... Alright, so we're gonna get, we'll rotate this thing, and then we'll do a round on it. Is that true? So we're gonna go by 45-degree chunks. So we've normalized our vector. So we're going to go from 0 to 1 in all directions, and we're going to go out from this. So the rotated vector is going to be 0 to 1. So it's going to be like 0. We need to see which direction it is. So alright, so if the F math of absolute value of rotated dot what are these coordinates? Let's see, what's the cosine of 22.5 degrees? That's 0.92. Alright, so if the absolute value is greater than 0.0761, then let's see, rotated dot 32. Let's see, dx dy equals 0 equals 0. We're going to say dx equals f math. Let's see, seal from the absolute value of rotated.x multiplied, well, we're going to do fmath seal to int. Yeah, so we basically want to take the absolute value, so when we seal it always goes higher. I don't know if the definition of the seal to int actually takes into account the absolute value or not, or if it takes negative 0.5 and goes to 0, or if it goes from negative 0.5 to negative 1, but this will take it to the absolute value from 0. Alright, so we're going to try this location. Alright, so it's going to be the mx plus dx and my plus dy. Can move is going to be true. So I'll try to go in this direction first. Alright, so rotate by the negative angle. So what we want to do is we want to find out if we should go left or go right. Do we have a get angle between vectors? Do you like USPS? You should save them for implantations. Adam is gone. What? Adam's already done? It's like midnight there, right? So he's toast. Alright, so we want negative angle. So have an actual angle equals angle. And we'll use our actual angle here. And we want to know if we're supposed to go left or right. So, what is the... How do we actually know if we're supposed to rotate by the left or right to start with on this one? If angle equals negative angle, continue. Alright, so what we want is that's kind of annoying. I wish this was easier. Easier, simpler calculation, but it's really not. So let's just digging myself a hole here. It's not working. Well, we got to get there first. Let's just call get angle from vector. And do it that way because I think it'll work better. Alright, the start domain is going to be the angle divided by 45 degrees. So if start domain is less than 0, start domain equals 0. We'll get there. Yeah, we just gotta keep working. It will be there. As we say, it is always just a matter of time. Alright, 0 is x, and then y defaults to 7. Alright, let's run it and see what we got. And we're just gonna tick this thing and see how it goes Do we have a number of ticks on our base tick function? Let's see, where is that? Tick and draw. Yeah, we do have a number of ticks. So I can just mess around with that. So let's take a look. We've got our we've got our texture that looks like a giant body part down there, which is hilarious. That tends to always happen with any sort of development. Drawing a picture, damn, working forever. Like one guy, he was working on a big gadget for a Facebook game, and it was a thing in the top left hand corner of the screen. It was like this big dragon, and then you click on, this thing, and like out would slide, this menu with all these cool buttons that you could press. And this guy spent like, a week on this thing, making it do all this crazy cool stuff. At the end of the week, he shows it off to the producer. The producer's like, dude, you just made a giant dragon dick expand across the screen. You spent all week, and that's what you got. What's what you got? You got this thing that you can click on. That's just, and he's just like, God damn it, and just went back to his desk. So let's see what these things are actually doing. It's angle is 90 degrees, domain is 2, go right is 0. Angle is 89 degrees, domain is 1? That's not true at all. We're off by a set number of degrees here. Hello, EG. Welcome back. I'm just working on some tick functions for this flow field, which are obviously wrong. Like, this thing's supposed to basically be ticking out, and we're supposed to be getting, these particles that are going to come out and generate our flow field. But it's, it's very obvious that our math is incorrect for this stuff. It's slowly filling up with, flow information, and after a certain number of ticks, we'd start getting some information going on, but it's in the wrong direction. Alright, so domain is 3. Alright, so let's see. Angle is 84, domain is 1. Why would the Alright, so let's do some math here real quick. The angle is 90 degrees, or 80 degrees, the domain is what? Alright, so if we have 80 divided by 45, we're going to get 1.7. We're going to floor that to 1. Do we want to round this instead of, like, it's going to be 1.7. The answer should be 2 for this thing. So why are we flooring it? Shouldn't we be rounding? Let's do round to int there. Is it harder to calculate everything first and then deal with the art, or deal with the art and then fix everything as you go along? I'm not exactly sure what you mean by your question there, but if you're saying, like, is it harder to, get all the information correct and then put it together to make the art, or is it easier to just kind of like start plugging in the art and then figure out what information you need? Because for me, it's much easier to calculate everything first and then make the art from there, because then all your information is correct, and you know if like you're screwing something up because the information is wrong, or you're screwing something up because you're just like, oh, I'm not panning this texture properly, like that's why it's wrong, as opposed to my flow field is just a pile of hot garbage. Oh, okay. Not exactly. Like, I kind of know what the assets are going to look like, and using placeholders is usually pretty easy. Like, you can get the idea behind what you want and slap something together. I think it's, if you start off with the assets that are super correct, you don't really know that they're super correct. All right, angle is 150, the domain is 3. All right, so let's see. 150 divided by 45 is 3.3, so I'll round that. And that should be fine. Go right as 1 on some of these. So it's looking like we might have some of the correct stuff here. But so if we set texture to flow field, set texture to paths, we've got this. So I got this path going along here. Set texture to particles. If we tick it once, we just get the single line. Where's the other line? Are we not ticking both lines? And those did move. Alright, so what's probably going on here is we're not actually ticking these things properly, and it's creating these waves. Alright, so what we've got going on is our spawn particles isn't working. So I'm just going to do for int32 I equals 0, I is less than flow field and paths.num. Alright, so we're going to do int32 index equals I plus random. Alright, so a random is going to be this random range, and we're going to do if index is greater than I, index minus equals the num. And we'll just look this up like this. And just get rid of all this trash. If index is greater than or equal to I, no, if index is greater than or equal to the number of things, we're going to subtract the number. So that should random around this properly. What do you use for stand-ins? Would you have some 3D cubes and shapes to throw around? Yeah, pretty much. There's just some built-in 3D cubes and other things like cones and all that. No problem, right? Just chuck them in there, and also, you know, making some rough assets out in Maya and throwing some basic stuff in there is pretty simple. And that's what Adam did kind of to start with, is he just put together a whole bunch of little, you know, random things like some rocks and stuff and chucked them in a level for me. And that's really all you need, because you're not really sure what you're actually going to need for your finalized assets. Like, we're still working on exactly what sort of materials and shaders that we actually need to get the look of the game proper. So if he spends a whole bunch of time like finalizing assets, the only thing that might be even final is like geometry, but even then, like, maybe our physics stuff changed. So it's better to work on it with placeholder stuff as opposed to like spending 20 hours on like all the boulders and rocks and trees and crap just for us to realize that the boulders and rocks and trees and crap that you made all have to be thrown out. Because, you know, like, we've discovered that the physics geometry means we can only have convex objects, and you made a whole bunch of concave boulders, and it's like, well, too bad, you know, like, I'm sorry. Alright, so we're ticking stuff. Alright, and what's happening here is it looks like our get angle from vector is just wrong or something like that, like, because we're not going in the right direction. Like, if we look at our output log, I don't see any angles here that are greater than 180, so we must have this get angle between vector angle is negative 160, right? Like, that's, so it probably goes from, you know, 0 to 180 and then from 180 to 0. So what we need to do is account for that in our function. So this get angle from vector, I'm actually going to go to that math utils, and I'm going to be like, this would be like, you know, positive pi to negative pi. I have it marked up here, it's radians. Alright, cool. So it's 0 to 180, so if angle is less than 0, then angle equals fmath, the absolute value. If it's 0, we just add add 2 pi to it basically, add 360. If it's negative 180 and we add 360, it's going to turn into like 270 and all that stuff. So we just say like, yeah, if angle is less than 0, then angle plus equals 360. So for 3D games, are hitboxes usually planes, or can you have a mesh as a hitbox? Well, hitboxes are always convex hulls, right? You're going to have either a sphere, a box, or a capsule, or rigged up capsules and boxes and things like that, or some arbitrary convex geometry. I don't think you'd use a plane for any hitboxes, because you need, you might use plane for some hit detection or something, like if you're doing some ray traces or something, but I wouldn't expect you to use a plane. So let's see if this tick actually spreads out. It's still just going down. Like, I don't see any of this stuff spawning. Well, we're spawning one particle, and it looks like it's off by 90 degrees, to be honest. Like, these particles should be trying to go this direction, to down and right, but they're not. So they're just kind of going the wrong way. So maybe we're off. Maybe we just need to add 90. Let's rotate it by 90, who cares? Yeah, I'd say for a lot of 3D games, I think it's a bunch of capsules strung together along like a rigged up object, where you have like your bones which get covered by your capsules. So like if you have a start and end for a bone, you have the length of the bone, and then you've got also like you can define some radiuses. Like usually they have their bone weights on there, so like the bone weights are mathematical constructs that define what vertices are affected by the weights of the bones, and you can kind of just like assume that that's going to be your collision box, is going to be your weight box, your weight geometry on there. So usually your 3D package exports the capsules that actually go around all the geometry. So it's really important to rig up a character properly for a AAA game or whatever, and you'll name all the bones, and the bones all have hitboxes, and they'll probably be capsules or whatever. And if you have like a fighting game or something else like that, like Street Fighter, they spend so much time on that. Like they'll probably actually have hitbox geometry specifically built into the rigging objects, and not use any of that crap. And they'll customize every single piece of it. If you're interested in hitbox stuff, you might look at, I think it's The Perfect Punch, which is it's not correct at all, is it? These things are still going the wrong goddamn direction, aren't they? Now they're going really the wrong direction. I wonder if I'm actually doing this right and I just can't see it. So let's just throw a blue value in there for the color so that we can actually see them, because it might be that there are black pixels in there that we can't see. Yeah, but there's a lot of ways easy to do hitboxes. And games do them all differently. It depends on a lot of stuff. Like, if you actually have a lot of people on a team making a game, you can kind of afford to have much better hitbox detection versus just having like some auto export geometry based stuff. And you can tell I'm kind of at the end of my rope for programming and everything, because I'm just like, I'm not even really trying to solve the problem. I'm just like screwing around, messing with stuff. I mean, like, I wonder if this number works, instead of like actually thinking about what I'm doing. And the reason for that is pretty simple. I've been working on stuff for like 12 hours, so that's always a good time to keep working, is when you've lost focus completely. Yeah, so I actually had things correct, I just couldn't see it, is what I think was going on. So I'm gonna get rid of this angle thing here, and for the spawn particles, I actually kind of want to make more particles than just the one. Like, I kind of like to spawn particles everywhere around it. So for every one of these, I'd like to like try to spawn 9 particles or something. Like for int, x equals -1, x is less than or equal to 1 plus x, and then for int y equals -1, y is less than or equal to 1 plus y. I need an x here. So what we do is do the same thing with int32ax equals node.mx plus x, and ay equals node.my plus y, and we just do the ax and ay tests, and that's how we'll spawn particles. And let's copy paste this as the particles value so we don't screw it up. So what I think is happening is like we're getting a bunch of gaps because we're like trying to spawn particles and it's going to kind of favor one way or the other. And what we want is to spawn particles and then move them all directions and everything. And if we're not spawning like a particle on the left and the right of our line, one side is going to get favored, and that's always going to be the side which is towards, it's going to be biased towards one direction, and that's not good. We want enough particles that we can just kind of fill and flood out this flow field area. Why aren't these things going out to the right is the question. Like, we're filling everything out properly, and these values are basically when things can't move, they're going to change. But we should be seeing particles go off to, the top right and all that stuff because they can't move down. I don't see any angles that are greater than 180 here. Everything goes the wrong way. Well, let's just try something real dumb. So we need start domain. Alright, so if back.x let's see, is greater than 0.5f, then domain is 1, 0, or 7. So if vec.y is greater than 0, domain is 1 or 0. Boston, Mass. Blueprints are definitely worth using. I would not use them to make the entire game, but I would use them and do use them for where they excel. Like, they're really good at just putting something simple together, and you always want to have a separation between your engine code and your kind of game-specific garbage town code. And blueprints allow a pretty good Wild West area to keep stuff contained. So definitely, blueprints have their place. C++ has its place too. There are certain things you cannot do in blueprints that you need to do in C++ and vice versa. Alright, so what we want to see is if... Yeah, so these are our potential domains for this one. I mean, I should probably just have a test here. So if vec.x is greater than 0.07, I mean, what is this? You're looking to start with Unreal? What sort of stuff are you thinking of doing, and what size of project? Alright, so if x is greater than 0.923, then start domain equals 0. And if vec.y is less than 0, go right. What does go right even do on this one?